Good day! In this MTOP Math video lesson, we'll be having a topic in grade 11, General Mathematics. The topic is rational inequalities. So let's start. So in this video lesson, we'll be solving rational inequalities. Our objectives would be, at the end of the video lesson, the students should be able to solve rational inequalities. Now before we go into the problems, there are simple tips recommended in solving rational inequalities. So let's have them. So number one, the left side of the inequality must be a single fraction and the right side of the inequality is 0. So what is important here is that a single fraction is in the left side, the right side is 0. Find the critical values. These are values that will make the numerator and the denominator of the left side 0. So remember, the left side is a single fraction, and the values that will make the numerator and the denominator, the values that will make the numerator and the denominator 0 will be the critical values. Now, next, the critical values will divide the number line into regions. Set up these regions in interval notation. So remember that the number line represents the set of real numbers. So the critical values will divide the set of real numbers into these regions. And lastly, select a test value in each region and test if the value satisfies the inequality. So we will be following these 4 simple steps in solving. Let's go to our first example. Solve the inequality x minus 5 over x plus 3 greater than or equal to 0. So step 1 is already done. The right side is 0. The inequality, the left side is a single fraction. So we will be going to the second step right away, which is again find the critical values there, right? So what will make the numerator 0? X minus 5, 0. We get here x is 5. What will make the denominator x plus 3? 0. So obviously it's negative 3. Now, we will have the number line drawn. So, of course, the middle value is 0. And negative 3 is obviously to the left of 0. And 5 is to the right. So, remember these 2 critical values, negative 3 and 5, will divide our real number line into this region. So, we're using the real number line as a visual to help us set up the regions. That is actually step number 3. So we're done with step 1, 2, and now we are now into 3. We will set these regions in interval notation. Now, the first region is obviously all the values left of the first critical value, negative 3. So all the values left of negative 3. So in interval notation, that will be from negative infinity to negative 3. Now, although the inequality has an equal sign in it, so greater than or equal, remember that negative 3 cannot be the value of x because it will make the denominator 0. So we'll be using a parenthesis, not a bracket. This means that negative 3 is excluded from our possible solution set. Now, the next region must be the region between the two critical values. So this region. So it's obviously from between the 2 critical values, negative 3 and 5. In interval notation, that will be from negative 3 to 5. Now, take note again that negative 3 should be excluded. But this time, since the inequality involves an equal sign, therefore 5 can be a solution. Therefore, we will use a bracket, meaning 5 can be included in our possible solution set. And obviously, the last region is this region, all the values right of our second critical value, 5. So this would be from 5 to positive infinity. Now, the last step. The last step is select a test value in each region and test if the value satisfies the inequality. So, this is the last step. We will select a test value. Now, let's write our test value here. Let's say for the first region, let's use negative 4. So I'm just labeling it test value. Obviously, negative 4 is here. In the second region, between negative 3 to 5, obviously 0 can be a test value. And then 5 to positive infinity, let's use 6. Now we will be after the signs here. So let's just mark whether what we will get is a positive or a negative. This time we'll be using a calculator to help us. Obviously, we can do this manually just by substituting negative 4 to our expression. But so we can answer faster in this video. I'll be using a calculator. So obviously, for the first one, we use negative 4 in place of x. So this would be negative 4 minus 5. Then negative 4 plus 3. So remember that the expression is x minus 5 over x plus 3. So instead of x, I'm using negative 4. Now, we will get a positive 9. Take note that we are not after the exact value, just the sign of the result. So we have here a positive result. Now, 0. Now, this time we can actually make do without a calculator. We have 0 minus 5. You know that's negative 5. 0 plus 3 is 3. So that's negative 5 over positive 3. That's a negative 5/3. So that's a negative. Then, if you use 6, you have 6 minus 5. You know it's 1. 6 plus 3 is 9. So it's a positive 1, 9. This is a positive. And now we just go back to the inequality that's given to us. And we are solving for greater than or equal to 0. Obviously, we should be picking the positive results from the test values, which are these two. So the solution set to this inequality is negative infinity to negative 3 union 5 bracket included to positive infinity. Okay, let's go to this next problem. Find the solution to the inequality x squared plus x minus 6 over x minus 4 is less than or equal to 0. Again, let's go back to the suggested steps earlier. Left side must be left side must be a single fraction and right side is 0. So as in this case, it's already is. So we are actually done with step number 1. Just mark it, check. So the next step is find the critical values. The values will make the numerator and the denominator 0. So we have the numerator is a quadratic. So let's solve for the values that will make this 0 just by simple factoring. You have here plus 3 and minus 2. So you have two critical values above. In the numerator you have negative 3 and in this factor positive 2. Now the denominator x minus 4, obviously the value that will make this 0 is x is equal to 4. So we have x is equal to negative 3, 2, and 4. So we have 3 critical values this time. So second step is good. We're done. So the critical values will divide the number into regions. We'll set up these regions in interval notation. So let's use again the number line as a guide. So this is the number line. Obviously the middle is 0. Negative 3 is to the left of 0. That's our first critical value. Then 2 and then 4. In that order, of course. Negative 3, 2, and 4. So we have this as boundaries. These 3 critical values. Obviously, we now have 4 regions. So this region, all values left of the first critical value, negative 3, in interval notation, that would be negative infinity to negative 3. Now, take a look at the inequality. So it does have an equal sign, less than or equal. Therefore, we use a bracket for negative 3. Now, the next region must be the region between negative 3 and 2 here. So again, negative 3 is included. And 2 as well. 2 is also included. because it will make the numerator 0, thus making the whole fraction 0. Next region must be the region between 2 and 4, our second and our last critical value. So from 2, interval notation, 2 again is included, we use a bracket. But this time, 4 is not included, so parentheses. Again, why is 4 not included? It's in the denominator and it will make the expression undefined. And obviously, the last critical value is this region, which of course would be from 4 to positive infinity. All values right of 4. Again, 4 is not included. So again, let's have this as a guide. Let's use a test value for each of the regions. In here, I'll use values less than -3. I'll use -4. I'll use, in here, I'll use 0. In here, I'll use 3, obviously. And in here, 5. Now, to help us easily get the values for the test value, again, let's have our calculator. Now this time, remember that you can get these values by simply plugging this to x, or substituting -4 to x, then 0 to x, and then 3 to x, then 5 to x. Actually, 0 is easy, because if you substitute 0, that's simply 0 squared, 0 minus 6, 0 minus 4. So that's basically minus 6 over minus 4, or 6 over 4. 3 halves, and this would be a positive. Remember, we're just after the signs here, guys. But anyway, let's use the calculator to help us here. So we have fraction x squared plus x minus 6, -4, so that will be a 16 when squared, plus -4, then minus 3. Denominator would be -4 minus 4. So what we'll have here is -9/8. So we're just after the sign, so this must be negative. Then again, if we use 0, obviously, we will get zero squared, so that's still 0, plus 0, then minus 6. Denominator would be 0 minus 4. That's why we got 3 halves, that's why it's a positive there. Now we use 3 as our next test value. We substitute into x. So we have 3 squared. See that? That's x squared. So substituting in place of x is 3. Then plus 3 minus 6. That's it. Denominator would be 3 minus 4. So we get -6. So this would be a negative. And then lastly, 4 to positive infinity, our chosen test value is 5. Let's put it here above. So our chosen test value is 5, so let's just replace the 3 with 5. Again, we can do this manually, guys, but to help us make things easier, I'm using a calculator. And you should too. Now we will get a positive 24, therefore a positive. Now let's go back to the inequality that is required for us to solve. Look at that. That's a less than or equal to 0. And obviously that should be a negative. Therefore we will use these two values. These two regions are our solution set. So solution set would have to be all values from -infinity to -3 included, union from 2 to 4, and 4 is not included. So that's it. So again, we're just following the same steps, guys, the 4 steps listed above as a guide. So we're done with critical values and then test value and testing it. That's it. For practice, use these problems to solve these inequalities and you follow the steps for more practice. Practice makes perfect. That's it, guys. Good day.